Hi everyone, this is Dr. Hess. We're going to use 3-column notes. Today we're going to talk about this type of problem that you can see in front of me. We're going to talk about sample proportions, confidence levels, and margin of error. By the end of this video, you should be able to solve a problem like the one you see on the screen. You might need to pause if you want to read it. First, you need to understand what a sample proportion is. So it's a fraction or percent. It represents the individuals or things out of the whole. So if you are looking at a class of kindergartners has 10 boys out of 30 students, your sample proportion of kindergartners for the school would come from that class, and you'd say 10 out of 30, or 10 divided by 30 would be 0.3333. And so a sample proportion means you don't have the entire population, but you have a group and you have data about the group that has a specific characteristic. So in this specific problem, we have students who set their own goals, and when they set their own goals, 5 out of 10 goals were achieved. So 5 out of 10 goals becomes 5 out of 10. Stick 5 divided by 10 into your Desmos or calculator, and you get 0.5 as your sample proportion. So here's an extension. What is the sample proportion for reaching goals when the teacher set the goal? So pause for a minute, read the problem. What's the number we're given? So we're told that 4 out of 10 students reached their goal when the teacher set the goal. So let's talk about level of confidence. So the higher the confidence, the more certain you are that the results are accurate. Statistics helps us come up with good ideas. We use data to come up with what we expect. We're never 100% certain about anything in statistics, but we can have confidence in our answers based on the data that we've collected. We're going to use the standard normal app that we've used before to help find levels of confidence. If you go to the comments in this video, you can pull up the app and follow along with me. We also need to understand what this Z alpha over 2 means. So you're going to see this a lot, and you need to understand what it means and where it comes from. It's a specific type of Z-score. And it's the Z-score, or the Z number, that's associated with the confidence level. And so in this problem, we have an 85% level of confidence. There's a few different ways you could say it. You could say a level of confidence, a confidence interval, confidence level. They all mean the same thing. So we're going to use the app. And so here are the steps to find what our Z alpha over 2 is. I'm going to pull up the app and I'm going to show you how to find an 85% level of confidence, find the Z alpha over 2 that goes with 85% level of confidence. So here's our app. We're going to want to click on between, and we want value from an area. And we want our area to be 0.85. So you're going to take your 85 and divide it by 100. We're going to keep the mean as 0, the standard deviation is 1, and we want the area actually between. So we've got 85% in the middle, and what it's telling us is if you have a Z-score of negative 1.44 and positive 1.44, the area between it is 85%. And so we want this positive value. They're always going to be symmetrical because that's what a confidence interval is. It's symmetrical. So let's go back to our problem. All right, so again, here are the steps, and now I'm going to give you an extension problem. Find the Z alpha over 2 for an 88% confidence interval. Go to that app and look it up. Pause and come back and check your answer. So you should have gotten 1.555 for your Z alpha over 2. Go back and watch it again if you're not quite sure what happened. And this may be something that you want to write down the steps and make sure you're clicking the right boxes so that you can do the right thing. Once you've practiced enough, it should become a little more natural so that you know what you're looking for. Okay, now let's talk about margin of error. What is the margin of error? So MOE is what you're going to see a lot for margin of error. And it's the range of values above and below a sample proportion, in this case, that we might expect to find the population proportionate. So let's talk about it a little more. So first, here's our formula. So we're going to find that Z alpha over 2. You need to know the size of the population. That's what N is. And so in the problem that we're doing right here, we've got an 85% confidence level. And so from before, we used that app and found that Z alpha over 2, the Z-score, when you have an 85% interval, is going to be 1.4. From the problem, we know that there are 37 students. And so our margin of error, here's our formula. We're going to put the 1.44 in the numerator, the top. The 2 is always a 2. Square root of 37, plug it in, and it'll give us a 0.118. Margin of error represents a percent. So in this case, we'll multiply it by 100, would have 11.8%. So it means that the real population proportion is we'll expect it to be in that range, and that we can have this range of confidence and error. So it has to do with the fact that we only have a portion of the students, we don't have all of them. And so we're not going to be able to find the perfect interval of what we expect, but this will help us know how confident we can be with our answers. So in this video, we talked about the formulas of sample proportions, margin of error, confidence level, and the Z number. We used the standard normal app. I'm going to give you an extension problem. So this is very similar to the one that we just had, but now we have a group of 50 students. And so you're going to find a margin of error using a 95% interval. So first think about what is your Z-score, and then think about the formula. What's your Z alpha over 2? What's your N? Pause the video and come back and check your answer. So hopefully you got a 1.96 as your Z alpha over 2. Your N was 50. And so your margin of error should be 13.86%. Let me know if you have any questions. Thank you for watching.